So this is going to be a really kind of short notice stream. Find it easier than just trying to record a video and uploading it. If anybody catches it, it might be interesting for them. Otherwise, obviously just watch the kind of recording afterwards. I think that's going to be most people that are going to watch it. So there was a lot of cool feedback on the first stream I did. A lot of people poked me afterwards and had a lot of discussions about their use cases, how they're using a bunch of things. Questions about how I see things, how they see things, pros and cons. And there was a couple of things that I didn't really go into or wasn't clear for a lot of people, and that was kind of my fault. Granted, it was 2.5 hours and it's a lot of data to go through. So I just want to quickly clarify some of that aspect. It's going to be super short and quick. So primarily, the biggest question was regarding what I was calling a spatial hierarchy. And that's something that kind of it's something that I took for granted, and I kind of forgot that a lot of even the game component models don't actually allow multiple components of the same type. They kind of do this composition approach. I think this is the CryEngine style, where you create an object and then you add the components, and basically it flattens it out into a single unit or character. And that's kind of basically what I alluded to with the old ye olde model approach, where all that the first steps were done was just taking what we used to do, split it into chunks, and then basically allow us to composite those chunks back into one object. I find that very kind of old school and limiting. In general, I find this whole one object approach limiting, which is why I kind of alluded that the game object component had evolved and allowed the multiple components. That's not necessarily the case in a lot of cases. I think Unity is also one component per type per object. Again, I don't have too much experience with Unity, so I'm not going to speak to that. And if you are coming from an engine where you do have that limitation, switching to an ECS is trivial because all you're doing is moving the logic from the components into the systems fundamentally. Most of your concepts and the way you work and you used to maps cleaner. And maybe that's why for a lot of people, the ECS is less of a massive paradigm shift than it was to me, for example. Now, personally, I feel the multiple components are beneficial for numerous reasons. And just to clarify this in the next couple of sections, I'm not going to refer to it as multiple single. I'm just going to call it an internal hierarchy. So the object has an internal hierarchy to it, and an external hierarchy where a logical abstract object is composed of multiple entities that are all in the world, and we just link them together via link components or attachment components or whatever you have. So that's what I'm going to call an external hierarchy, so that the object itself doesn't know about its hierarchy necessarily. It has to kind of follow the trail and figure out what it actually owns in composites. Now, we're going to just go through some quick examples. I'm not going to go into a lot of detail. So I used the gun example in the previous one, where you would, in a external hierarchy kind of setup, you would have like 12 different entities with 12 different meshes and that kind of thing. Same thing for characters. In this case, like I took a thing from Cyberpunk where it's like, yeah, you have 8 slots. There's probably more if the beard and the hair are separate meshes. I don't exactly know how they composite the characters, but let's say it's 8. So you could easily see it modeled in this sort of an approach where with the external setup, you have an entity per mesh pretty much, and then you have a link component per entity that basically defines the relationship to its parent. That basically says, hey, I'm attached to this mesh at this bone, or I'm attached to the capsule, whatever, you know, and this is where this kind of gets a bit already unclear if you compare the two setups. In the one, I kind of understand immediately looking from it, the hierarchy, what is attached to what. In the other case, I kind of have to dig in and look into it. And I'm going to get into some tooling a bit that does simplify some of this aspect, but it also has a really nasty disadvantage. But just modeling it this way, it's a bit clearer for me, at least, with the kind of internal hierarchy. Also, I deal with a lot of new programmers to the industry. And when I mean new, I don't mean like juniors. I mean literally fresh, like intern. Maybe they have a comp sci degree. Maybe they're a game programming course or something. So for them, they don't have necessarily any background. So me trying to explain to them the setup on the left is very difficult for them to grasp, because in their head, they're still trying to kind of parse all the complexity of building a game, the engine, the tech, the this, that, and then then trying to understand, okay, wait, my character is actually multiple meshes. It's not just a single thing. And then these meshes are all separate things that are linked together. It kind of becomes a headache. And additionally, which I didn't kind of go into much detail, programmers are not the only target audience for the entity model. This is kind of the basis for all your LG tools and all your scripting. So you have a big target audience in terms of your LDs, your mission scripters, your designers to some degree potentially. It's not just programmers that are dealing with necessarily this aspect, because programmers are generally not building your levels, they're not building the setup, they're not doing any of this. So let's talk about one really common aspect and problem we deal with. At least in our work in AAA, for a lot of the time, we have a lot of attachments that we deal with, weapons, props, what have you. And it's a very simple problem. It's fundamentally saying I need to attach something to some character at a specific, and I'm going to use the word socket, not necessarily bone, because sockets are attachment points, but they're not necessarily tied to bones. They could be a offset of a mesh. They could be, it's some aspect. It's usually defined within the mesh, but it may not be attached to a bone because we have sockets on static meshes a lot of the time too. So it's basically an attachment point as part of the mesh. And it usually has a name, and we reference it by saying, give me socket A, give me holster, give me attachment point, whatever. It's usually done by name. And so this is a very common use case. So usually a gameplay prog or even an LD in scripting will just say, hey, attach pistol to that character at socket pistol holster. That seems fundamentally simple, but the first question is, which mesh contains pistol holster? It's not going to be, if your character is split into 20 meshes, which mesh contains that holster? And it's not always going to be the same mesh, because maybe one character has a chest rig where that holster's on the chest. Another character might have it on the pants, on the leg mesh. When I switch out my clothing, maybe all of a sudden I switch from leg to chest socket. That has to be handled, and that has to be reattached, managed, controlled. And this isn't just for meshes like weapons or whatever. We attach sound emitters. For example, sometimes we have attacks that have like a spatial sound aspect to it, or we want to have, I'm trying to think of a good example. But okay, just take my word for it. Sometimes we attach spatial emitters to characters, and we want them attached to a specific point on the character, just so that we have a proper 3D position for the audio. VFX is a very common one that goes attached to, for example, weapon tips or character leaf joints, or parts of the mesh where you have a glowing thing on the back of your chest or whatever. And those are attached to specific points. Stims are another big thing. Like say you trigger a stim and you want that stim to be spatially accurate. You want to do it at, let's say, the foot of the character, or you want it to be coming off the backpack because the backpack is beeping or something like that. So again, this is a very common use case for LDs, programs, everything. And what they want to do is just as a junior coming in, you just want to say, okay, I want pistol attached to the pistol holster. And that's all he wants to care about. He doesn't want to give a shit about find me whichever entity it is and that kind of thing. Now, if we go with the external hierarchy kind of thing, you kind of constantly have to look through the hierarchy for this thing. It's like, where is that socket? Start at the root level of the character and then traverse the hierarchy and say, do you have the socket? No. Okay, find me your children. Do they have that? And so on. Now, this is kind of similar in the internal case, except you're checking less you're checking the same number of components, but it's a lot clearer. And the other thing is you can build it as a generic system on your actual entity. So you'll still have logic in the entity, and that entity will manage all of those attachments for you. So you don't really have to care. You could put a function that says literally attached to socket, and then that's the only thing you have to care about. And you just expose that to your level scripting, you expose that to your programmers, and you have a single code path for this kind of thing. Now, you can just say, well, I can make a helper. Yes, that's true. In the other case, you can make a helper that's always kind of traversing hierarchy, finding stuff, whatever you need. It's valid. The problem with helpers sometimes is that people need to know that that helper exists, and they might not know where to look necessarily. So if you've come across this in every engine where you have like 5 different versions of the same function because at different times programmers didn't know where to look, or they created their own utility and didn't tell anybody. And That's kind of the thing with the splitting the functionality to different detached pieces of code. If somebody doesn't know that exists, that person's going to probably reinvent the wheel multiple times, or you'll have multiple people in parallel reinventing the wheel because they just simply don't know that that thing exists. And that happens when you get like a licensed engine like Unreal and you start trying to work on it. You don't know the whole engine, so sometimes you start building functionality that already exists in just a shittier way because you don't know it's there. So for me, having the internal hierarchy allows me to kind of provide a single code path that everybody can use, and that will reduce the amount of like bugs, issues, cognitive load, teaching, that kind of aspect. The other benefit is that, again, the attachments are attached to an entity. So if we start messing with our hierarchies, switching out meshes, doing that kind of thing, at the internalized version, your attachments are done at the highest level, at the entity level. So you don't necessarily have to give a shit what happened to that hierarchy. All that you know is you get a signal saying, hey, my internal hierarchy changed, reattach this thing, detach, attach. You know, it can be done automatically, and nobody has to be the wiser that that thing happens. And LDs and gameplay programs don't care. They say, well, I attach this thing to this pistol socket. I don't give a fuck what that socket is. If that socket moves, if it changes, it disappears. All of that stuff gets kind of handled for you. Whereas in the external case, like, again, every system might do something different with this attachment because there's no unified way to do this. Again, you don't have any logic on your components. Your entities don't even exist conceptually in the ECS case. So it has to be done via a system. And again, there, if multiple systems have to deal with this separately, you're kind of forced to putting it on a helper. And then you have the problem of discovery, pretty much. This slide kind of covers what I just mostly covered. Again, I find it, again, most of the stuff is my experience and your mileage may vary. I just find it as less chance for mistakes and lower cognitive load for me to think about this setup. And having a single code path generally feels to me better than potentially having a free-for-all situation. Now, I'm going to just kind of show you again. I'm going to dig into this one a little bit more just so people understand, because this was the biggest point that everybody came back to me and said, hey, we don't really understand the hierarchy aspect. I don't really understand how you manage it, how you deal with it. So what I mean is when you do an attachment in the kind of separate, like the external case, you're attaching one entity to another, but you don't have any context anymore of why that attachment exists. Was I attaching a weapon to a thing? Is it just a component to a component as part of a character? Is it cross-character setup? It becomes difficult. And if you have multiple characters that are doing something like a synchronized animation, where they have multiple attachments, and then there's an attachment between them, that hierarchy becomes complicated at some point because your boundaries become unclear at some point. Where does one character start? Where does another character end? Right? Because I'm just traversing a set of components at one point, and it's like, at which point are these separate? Like, I'm going to use the word entities, but at which point are these separate conceptual units? Whereas with the internal hierarchy case, it's a lot more clearer. It's saying, okay, I have a character and I have a weapon. I'm attaching the weapon to the character. It's a lot simpler. In terms of reasoning, it's a lot simpler to explain to an LD. It's a lot simpler to explain to a junior programmer. Hell, you could even explain this to a producer to some case, saying, look, the weapon is attached to the character, the hand, versus saying, hey, component 15 is attached to component 27. You know, I mean, you could always argue we can abstract that away, you can create helpers and all kind of stuff, but again, mileage may vary. The other issue that I kind of see with the separate parts thing is physics. It's something I didn't touch on too much, but you kind of do lose the parent context with the separate components. So let's say I have a backpack that's a static mesh attached to a character mesh, and I want that backpack to have a physics representation. So it has a physics shape. So I create that physics shape, I put it in the scene. Normally your physics system will basically say, okay, for this entity, I create a physics actor and I create the physics shape and whatever we need to do and bind it there. And I add the entity ID into the user data or the filter. And it's in there. So now I raycast into the scene and I hit the backpack. Cool. So I get back the entity ID. What character did I hit? I don't know anymore. I now have to say, find me this entity. Does it have a parent? Does that parent have maybe a character component? I don't know. How do you define a character? You have to specifically look for some set of components that will represent a character, right? Because your entity ID is just, well, it's a component ID practically at this point, right? You need to find that character. And that's going to be a very common use case for gameplay where we're doing things like, oh, I stepped on something. Was that a floor? Was that a character? Was that a vehicle? There's a lot of times where our raycasts need to basically tell us information about what we hit. And if I hit something, I need to find out what that thing is. If it's just a mesh, I need to find out what the conceptual entity was for that. Now you can also say, well, you bake a character ID into the physics shape. That would be maybe the first argument. So like you add more information to physics shape. First question is, what defines a character, right? What if it's not a character? What if it's sort of a complicated prefab? I still want to know that is one unit. What do I bake into this thing? That becomes difficult to like understand. It's like, well, I hit a mesh, I get back some data, and that data tells me what exactly. You could create rules of saying, oh, we put character details and we put that, but then you're bleeding in your kind of game setup into your generic physics system, which is kind of bad because now you've got a tight coupling there. If you start messing with your gameplay setups, you're constantly touching the physics system, which doesn't make any sense. It should be completely a black box where it's like, well, I hit the shape tells me what it is, and I have the information I need. So something like Unreal, it makes it easier because you hit the component and the component can tell you immediately which actor it is. Same thing in my engine, it's like you have the parent context. So when you create any shapes, you can put the entity ID in there, but the entity ID contains all of the setup for that logical unit. And that simplifies a lot of these lookups, a lot of these kind of crazy setups. Another thing that it allows you to do is it allows you to create physics aggregates. So if I have a complex static mesh setup, let's say I want to have a vehicle that has a skeleton, but all of its actual pieces are static meshes, because I want to be able to like shoot pieces off the car while we drive and have them just fall off and land on the ground. What I can do initially is I can create the shapes for them and I can put them within one actor for that car and have that actor in the physics world, so it's a bit more complex. I can make 20 physics actors, but then there are some issues with that. Also, rigidity of those objects. They're separate objects if they are simulated. They're not necessarily a single shape, so they may behave differently. You have a lot more control to some degree having the internal hierarchy, because you kind of, again, have information about what this entity is composed of and what those shapes are. So for example, and this is something that I'm not 100% like on board with necessarily, but Unreal will weld physics bodies together in the same actor. So if you have a hierarchy of meshes that have physics representations, like shapes and instances, it will actually weld them together. It'll treat it as sort of a rigid setup, so that I can build like, I can create a bunch of boxes and bind them together in like an L shape, and the thing will behave like an L shape kind of thing. That can be very powerful and very kind of useful in some cases, but also just being able to aggregate your physics object together, especially for things that are necessarily maybe not static or whatever, or they move as a unit, that can be a big optimization. I'm not necessarily a physics programmer, so I'm sure that actual physics programmers may have more use for this or better examples, but it's just something that is worth mentioning. Another headache is, for example, ownership issues. If I have a giant scene, I have a backpack. It's like I hit a backpack, which character owns this again? We have to go up that hierarchy, we have to search. And maybe for a render program, it doesn't matter because he's never doing this, but for gameplay, holy shit, this is something we do all the time. And you're going to spend a lot of time just traversing this hierarchy. One thing to mention on performance here is, I don't know, I'm not going to speak for every ECS out there, but a lot use entity IDs for these links. So you're constantly sort of dereferencing stuff. Now, if you have pointers, at least on x64, there's a good chance that it's going to prefetch that pointer in advance for you, because it says, oh, there's a pointer, potentially you're going to access via this branch, so I'm going to prefetch some of the data and it might be in the cache. So I have like an explicit hierarchy of my components via pointers. There's maybe a good chance that that's already going to be pre-cached. If I have just entity IDs, I'm not so sure that's going to help you in any way. It's, those kind of things, though, a bit like trying to reason about the pre-cacher, the prefetch and caching is something where I'm not too sure if it's even the same across all x64, if it's entirely like hardware dependent. But I can see how in the one instance there could be an optimization opportunity there with the pointers. Whereas if you have those entity IDs, that's something that, again, you have to do lookups and potentially you're hitting different tables, different memory, all that kind of aspect. It's something to be aware of too. It's not necessarily the same cost to traverse the hierarchy in both instances. Coming to the LD tooling aspect, here it's kind of more of a kind of usability. If you have the external hierarchy, it means that all those entities live in your scene. And so they're going to show up in your outliner. Whereas with the internal, like my character that's like my gun that's like 20 meshes, it's not going to show up as 20 items in that outliner. It's going to show up as one. It's going to say weapon. And I can click on it and then I'll get a different view and that'll show me what's the internals. That, if you have really complex AAA setups, our levels are already nightmarish in terms of complexity and item counts. Now, if all of the internal hierarchies are now spread out and exploded into the outliner, it makes that relatively unusable to some degree. And then you have to sort of start investing in tooling and prefabs and other kind of things. In some cases, you might want to start adding tooling like, oh, if there's a character component, then hide all meshes underneath, because in the outliner, usually there's sort of a hierarchy displayed, but that hierarchy is sort of inferred from like link components and those kind of things. No, it's not an explicit hierarchy. It's like, oh, this component is a link component, which means that I need to nest it in my tool. So you're starting to bleed a lot of your functionality into the tooling. So maybe you create another component that's sort of like a link component, but slightly different because you have a different use case for it. Now your tools have to understand what that component is and how to display it. And that can become, a maintenance burden over time, depending how it's implemented. Also, simply from a performance aspect, if you have an outliner with like a million objects in it, it's going to be slow no matter what UI approach you're taking. So you need to kind of find ways to, well, never mind it's slow, it's going to be impossible to humanly parse to some degree. And I also find that kind of internal hierarchy removes a lot of that complexity. And yes, you can see prefabs and whatever, they have their place too. But there's sometimes we just want to do unique setups and we don't need to like make a prefab for every single specific per level instance of something that just occurs once in the game. Another question is to do with this kind of external internal setup is how do LDs interface with the system? Like a lot of the times they are doing things like moving meshes around, spawning stuff, playing VFX sound, setting up big puzzles that are environmental that then they're controlling entirely in the level scripts, all those kind of things. And they need access to the scene. And that has to be sort of easy for them. And a lot of the times they prefer to work with names and strings. So they want to say like, hey, give me component that's called propeller on this character or whatever. Either your LDs have to be very technical to deal with like this explosion of separate components and meshes and things, or you need to start building abstract tooling on top of that to basically simplify a lot of the stuff for them and abstract it out for them so they can logically work on how they think. Because again, programmers are not the only people that are interfacing with this core system. So there's maybe a good analogy is to think of the internal hierarchy as more of a prefab system. It's like a very simplified version, but it also allows you to take one of those entities and write a script that works on that entity and basically have like a coupling between that script and that entity. And then you can do validation. You say, well, if you change the entity setup, like remove a component, rename a component, now your script will fail to validate. That's something you can do because you have a kind of a package of your entity with all of its internals, and you have your script that works in that specific package. If you don't have that packaging method, you do need to build something else and some more complexity. Potentially you end up having to build a prefab system and then you have to have run scripts on prefabs, or you do the free-for-all case where it's like you have to just operate on the scene and somehow group things. You still have to invest in tooling and other sort of like some simplification for your LDs. And there's a lot of questions. How do you like give them good access? Like, how do LDs trigger state changes via an ECS system? If all you have is an ECS system, how did an LD say, well, now trigger start playing this animation, stop playing this animation, spawn me this thing? Like, oh, that mesh now needs to change its material. Oh, put an outline on this. There's a lot of those kind of things. And then you have to start thinking, like, is it flags and components? Do they talk to the systems? How do they access transient state in systems? And this kind of thing can be simplified a lot by just saying, well, access this actor, you can access the components. A lot of the data is there. There's functional components saying, hey, you need to switch internal state and that kind of aspect, where an LD can understand this more. It's easier to explain, right? Most of this is coming to not necessarily what's the most efficient programming approach. It's more what's the most efficient kind of mental model that you can provide to a user. Performance, we can get most things to be performant within reason, obviously. But trying to explain something very complex to a group of people that are maybe not very technical, have a very different skill set, can be challenging and can cause a lot of friction within large teams. So that's something to kind of think about too. There is something to be said about Unreal's blueprint. There's a lot of things that I don't like and I find kind of problematic within their implementation. But fundamentally, it's easy to use. It's very obvious. It's very kind of intuitive, and pretty much every sort of LD non-technical programmer, not even programmer, like non-programmer that comes into contact with it loves it, because fundamentally they can hit the ground running. Whereas I've hit other like level scripting tools where the learning curve is extreme, primarily because it's trying to, there's no sort of thought to how an LD is supposed to interface with the object model, because the program said, well, I'm going to do something that works for me and blah, blah, blah. And you build something and then says, oh shit, I have to do tooling, and becomes an afterthought. And that's something people need to kind of think about too. It's like, it's you can't just build something and just say, well, it's some other team's problem to worry about how they're going to do mission scripting and level scripting tools. It's a little short-sighted to think that way. And that's where we end up with a lot of like tooling issues, and why sometimes these licensed tech engines look more attractive than your internal stuff. It's when in fact, like, it's a lot of smoke and mirrors. It's more just, instead of investing in like tooling locally and trying to understand use cases and improving that, we sort of just try to, people like, I'm sick of this tooling, I want to go for something simple, and they go for something simple, and then you have another set of problems. Long story short, don't ignore these kind of things. Another topic that sort of came up a lot was the scalability aspect of how ECS, for a lot of people, they find it simpler to just, they find it cleaner, it's more compartmentalized, they make some arguments. But then talking with a few of them, I asked them how they would solve certain problems, and a lot of common things kind of came back. Is people acknowledge that there are issues with these systems potentially becoming monolithic, of like having all your logic for certain aspects kind of being in one system, and you end up super branching. You end up with like a lot of different things in one system, to the point where it becomes, we go back to the old school monolithic characters, where it's impossible to make a step forward because you might break 5 different things. You can start adding these component types to do flow control if you want to have a single system. So you would say like, oh, I create this component thing just to have a different signature, so that goes into this, either a different system or the system internally will branch on that. And it can add a lot of friction to non-destructive prototyping. I'll come back to this exactly in the next example. And then a lot of devs actually seem to use ECS systems as just an update function call. They go in the system, they say, oh, I got the update, so now I forward the call to another system, like run animation or run behavior tree or something. And at that point, it's like, okay, so they admit that like doing, let's say, a lot of the gameplay aspect of it doesn't fit necessarily, and so it becomes more of a low-level system. And then they have additional gameplay systems on top of that, which are built completely separately to that system, so they're kind of working outside that. And then the question is like, what was the entire point of this whole thing if like a lot of people start to kind of work outside of it for their explicit problems? It's like genericity doesn't necessarily exist very well. It's like you're never gonna build a perfect system for everybody, but at least like if you build something, try to cater it for the general case, not the special case. And what I meant by the code scalability aspect is you have, let's say, a system that might over time evolve. Let's say it's a health system, and inside the health system, the designers one day decide, vehicles need to be handled very differently, and bosses need to have a completely different flow in terms of like how they take damage and how the health system works. Play and AI very different. Destructibles and LDIs level design ingredient. Again, very different use cases potentially. Maybe the one doesn't even take damage, or it only takes a specific type. Again, you can make the argument here, well, we'll build a super complex health system with rules and custom logic of being able to handle everything in one system, and then everybody can just write like logic. You basically end up building a separate programming language, with all the different rules and all the different values and all the different parameters and stuff. And that's not going to scale. You're going to now you're going to create yourself several new problems trying to solve the original one. Another option that you could do is you could basically say, well, we don't want to go this route. This obviously is going to be a problem long term. We create separate systems. So we create a player health, an AI health, a boss health, vehicle health, whatever. Now there's going to be probably some shared stuff. So naturally you'll create a shared util that works on those health systems, that each system can kind of use the same functions. And, we can still have some sort of code reuse. This kind of starts to break down a little bit is that, let's say our health component has a lot of settings on it. Like maybe it's got a lot of like properties, 20. But then the boss needs 3 more. But then the vehicle needs 2 more, but not the same as the boss ones. And then maybe player has some additional data that the AI doesn't. What do you do in that scenario? Do you copy paste them into separate components? Well, if you do that, your health utils at that point start to break, right? Because they don't have a shared base. Now, like they have to handle those types explicitly. So now you have duplication, potentially you health utils. You could do the other option is you put everything in one place, and then it's up to the designer or the LD to figure out what set of values are applicable to this specific entity that I added this component to, because, like how do I figure out what set of values I have to set and which valid and what's not? That has a big thing, and it's a big mess. At some point, nobody knows what does what and what can be removed and what's used and what's not. The other option is you could derive the components. Again, you have the issue with the system signatures and all this kind of things. You could also, if you wanted to keep your shared utils, you could maybe create an external struct, and then the component has different structs. Kind of the mixin approach, where you basically composite multiple different structs inside of the thing. You have like a vehicle health struct, a player health struct, this and then. But again, it comes back to the everything has all data kind of approach, and so you might have a lot of duplication there. And it kind of makes it shitty to work with, because you may have vehicle.health amount and you might have AI.health amount and something like that. It's kind of painful. And the final thing you could do is you just work around the whole fucking thing, and you just say, okay, well, my health component just has a pointer to a config or something else that maybe has derivation or polymorphism. And then the system basically reads that config, says, oh, you are of type blah, execute or whatever. And it, you have a completely separate health system outside the thing, and all you use your component and your system for is to read the config for that specific character and execute it in the external system. That's what a lot of people seem to be doing. And there's not necessarily anything wrong with that. But it just kind of feels like you're working around a fundamental issue in the system. Like if you told me initially that ECS was just like a low level, just for engine systems, blah, blah, fine. I can kind of buy into that. But if you tell me it's like a general system for everything, and then half the time people that it's not me, like I've never really like shipped a game with an ECS, but I'm talking to people that have, and they're pretty much all of them telling me, yeah, in some cases we're branching out, we're doing this, we're doing that. If they are hitting those issues and kind of working around them, there seems to be a fundamental issue in some place. Now, I'm not saying it's shit and whatever, you should like dump it or that. You're free to make your own choices and do your own kind of like decisions. What I will kind of say at the end is, and one thing a lot of people did kind of say, and I saw it in a few of the forum threads that spawned from that initial stream, people saying, well, it makes sense to me. I don't see what the problem is. Everything is super clear. And, you know, like the implication is, well, you don't understand. You're too stupid to get it, whatever. And I'm going to use a good example from C++, where I can give you some code here and I can guarantee you, like, there's a group of people out there that understand this and it makes perfect sense and it's great and elegant and clean. I don't fucking know what's going on there, right? I have zero fucking idea of what that code is doing. It's all templates and standard functions, and there's even syntax in there. I don't even know what that syntax is because it's modern C++. And who knows if that or is actually an or if it's something else, or if it's a, you know. My point is there's a lot of cognitive load here, which makes sense to some person, but that person is maybe not your entire user, the people that you're targeting to use this thing. So maybe you need to step back and say, okay, maybe for you this makes sense, but what's the lowest common denominator? It's sad to say, but we're losing tech skills in the industry right now. It's a lot of new people coming in fresh. They've never had to necessarily work with too much low level or building their own tech. They know existing engines. They've worked with Unity. They've worked with Unreal. They have a really hard time kind of understanding how things work at the base level because they just never taught that, or they never have to think about it because we have tools available right now. There's no reason for somebody to understand how rendering works at the base level or how serialization works because, you know, we have Unreal, we have Unity. That does serialization for me. I don't need to care. And so the group of technical users are shrinking fundamentally. And yes, maybe for a group of us, we can kind of look at some complex model and say, yeah, this makes sense for me and it's elegant, whatever. But does it make sense to an LT or to a junior gameplay programmer? I don't know. And that's something people need to stop and think about. And maybe, again, even within our domains, maybe it makes sense to like a render programmer that only cares about his specific use case, but it makes zero sense for somebody in UI, for example, that deals with completely different problem set. You know, like a lot of the time engine programs are dealing with very small, well-defined problems that are very compartmentalized, and they don't really have a lot of like dependencies on 50 different systems and whatever else. And so for them, it's kind of, over time, they kind of forget that there is this crazy, messy complexity that comes from constant design changes, constant iterations, constant, let's try this, let's prototype this, I don't know how this works, let's try, you know, that mess. It's inherently just organized chaos. And that use case needs to be covered, and you need to provide simple, clean tooling for that. So again, I'm not saying that, you know, like each to their own, everybody do whatever you feel comfortable with and you enjoy doing and it works for you. Like that's kind of the nice thing, is we can all work how we want. I'm just saying is that, like, don't just discount something because, well, you know, my approach is great and it's cool and it's, you know, I'm smarter than other people, and there's a bit of that elitism bullshit going on. So just less fanboyism, more objectiveness, I guess. Anyways, that was kind of it. I just wanted to cover those points. Pretty sure there's like not too many people watching, so any questions, you could always just poke me on Twitter or just message me or whatever, and then we can chat about it. I'm always interested in hearing other people's experiences with this stuff. And hopefully it's clarified some of the points where people were confused in the previous case. So anyways, have a good one and enjoy the rest of your weekend.